Hey everybody, it's Mrs. Neller, and I would just like to give you a little bit further explanation about the animation activity that I would like you to do in Desmos for one of your little mini projects for the Google Advanced Math in the Real World slide activities. So here's the slide that talks about the different equations that I'd like you to try out in Desmos. These equations we're going to see in chapters 5, 6, 7, and 8. So we have some sine and cosine and tangent functions. We'll see those in 5 and 6. And then these other ones that start with r equals, those are polar equations, and we'll see those in chapter 8. Okay? So in order to graph these, you need to go to Desmos. It's just desmos.com. Okay? Over on the side here, you can log in with your school account. Okay? And then once you're logged in, just go to Graphing Calculator. Okay? And it'll pull up a blank graphing page for you. And we're just going to type in those equations that were in the Google slide. So we have y equals a times sine, and then we have to do in parentheses like this in Desmos, k, and then parentheses, x minus b, and then we have to double close the parentheses. So I typed it that way in the Google Slides because that's the way you need to type it into Desmos, okay? Don't be nervous though, Desmos is super intuitive. You just start typing. We do our parentheses, k, parentheses, x minus b. And then you can see that Desmos will pop up the double close parentheses there, so that's good. You don't have to type them in even, it will do it automatically. And then down below it says add sliders. Now this is what you want to do. You want to have these sliders. The sliders are going to help us do the animation. So we have a, k, and b. Those are different variables that we added into the equation. Normally the base equation is just sine of x. So x isn't going to be one of our additional sliders that we can manipulate and animate. X is just part of the equation. So then hit all, and it will finish the equation for you. We'll put the parentheses in there, and it will give you the sliders. And then over here, you can see that the graph is graphed. That's our sine wave, okay? And you can zoom in and you can zoom out. That's one of the features that I really like about Desmos. I'm going to try and make my window go from like +10 to -10 so we can just see a little bit more of the wave. Now here everything is set to 1, okay? So you can leave it like that. When we're going to animate stuff, we're just going to hit the little play button, but we can adjust the sliders if we want to. We can make these values from -10 to 10 be anything that we want. But for A, it's okay to leave it from -10 to 10. For K though, I think it's better if we stay in the positives. It's okay to be negative. That's just going to flip the graph upside down. But let's change this. So to change the values on the slider, you just click on the number. Okay? And then we can make that value go, let's go from 1 to 10. And then the steps is just like in your graphing calculator. It's how you want it to count by. So it can count by ones, it can count by a half, it could count by fives, it could count by tens, whatever increment you would like. Okay? So once that is set, you can just hit enter, and then the slider will pop up there for you. B, this is okay to leave from -10 to 10 as well. Now when we get into chapters 5 and 6, we're going to learn what all this stuff is. A is going to be your amplitude. That's how tall the wave is going to be. So if I click play here, you can see that the slider starts to move and the graph is moving up and down. And the negative values make it flip. Okay, so there you can see, oh, A is the amplitude. It's how tall the wave is. Okay, so I'm just going to stop that at some random value there. K is actually what's going to affect how many waves we have in one normal cycle. So as we hit play to animate that, you're going to see more and more waves appear and then decrease as the number value gets lower. Okay, so that's something else we're going to experiment with in the sound wave activity that I have for you. Okay, so that K value affects how many waves there are, and how many waves there are is also called frequency. It's how frequent the waves go through one cycle. B is what moves the graph to the left or to the right on the x-axis. So if you click play, you can see that it moves to the right and then it moves to the left. Okay. And of course, you can animate all of them at once if you'd like, and then you can see a really cool animation go on. So this animation, you know, it's not like the Pixar animation. Hopefully you've watched that little video about the Pixar animation. I just think that's a cool concept that you don't need to know a lot of math in order to animate something. Okay, so we're not animating Woody or Ms. Incredible or Elastigirl or anything like that. But we can animate functions and we can make them move. Okay. So I'm going to pause those for now. One of the other equations that you need to try is where you take that same equation and you just tweak it for cosine and for tangent. So we can just go to our original equation here. We can just highlight sine and put tangent in. Okay. Let me do cosine first, actually. Cosine. So the cosine wave looks very similar to the sine wave. We're going to learn that the cosine and sine waves just start at different locations. Okay, so if I move this to 1, let's see if I can get it to +1. There we go. And let's move B to 0. There we go. So there's our standard cosine wave. So a standard cosine wave starts at 1, and then it goes down to the x-axis, goes down to -1, then it comes back to the x-axis and goes back up to 1. The sine wave starts at 0. Okay, so the sine wave would technically start back here at 0, and then it would go up, come down, go back down, and then go back to 0. So that's the only difference between sine and cosine. But again, you can just play with these sliders. You can leave the values set as they were. You can animate all of them, and you can just see that, yep, this looks very similar to a sine wave. Okay, and we'll learn how you could actually write a function for a wave like this. When you have this given information, you can write a function and you could make it a sine equation or you could make it a cosine equation. So we're going to learn more about this. I just want you to get exposure to the different characteristics of the graphs. Now if we do tangent, tangent looks a lot more funky. Tangent isn't a wave that goes left and right, it's a wave that goes up and down. And oops, I need to have an A value there. Let's try and make it 1. Let's make our frequency a little less. There we go. And then for our B value for tangent, that's still okay. Maybe for if it's negative, it's just going to flip it. Let's see if I can get it to 1. There we go. For the K value, maybe let's change this one just so we don't have as many waves in one area. So for tangent, for our A value, for our amplitude, if we just animate that one, you're going to see that the graph stretches. It gets a little bit taller, and then it gets a little swoopier in the middle. It switches when it goes into the negatives. It flips directions. Okay, so it just gets a little swoopier there in the middle. Okay, the K value is how many of those little waves we're going to have in a given interval. So you can just see as the K value gets bigger, we get more and more of those little swoopy lines that go from the top to the bottom. Okay. And then B again just moves it left and right, just like it did before. So those characteristics that apply to sine and cosine also apply to the tangent graph. And if you want to animate all of them at once, it looks kind of cool, looks a little weird, a little trippy maybe. Okay. So it kind of looks like the lines are dancing. They're dancing to some cool music. I like to call these John Travolta waves because one end is going up and one end is going down, kind of like dancing in Saturday Night Fever. Okay, John Travolta was in that movie, so that's just kind of a pop culture reference there. So I'll go ahead and I'll slow these down, wait for it to get positive there. Okay. So that's our sine and cosine and tangent graphs. The other ones are going to be our polar graphs. So these are going to make circles, and they're going to make hearts, and they're going to make flowers. So it's just really cool to learn a new shape that we can graph. So in Desmos, you can turn off a function just by clicking the little graph, the little colored circle there to the left of the equation. So we'll just turn that off. These sliders we might need for our other functions. And then if you click down below, go down below your sliders and just click in that empty space, and it'll pop up a new box for you to type a new equation in. So these equations are going to be R equals. We'll learn more about why it's an R when we get to chapter 8, but that's just how polar equations start. Instead of X's and Y's, they have R's and thetas, okay? So we're going to type R equals A sine theta. Now to put in the theta, you just start typing the word, and then Desmos will pop in the symbol for you, the symbol for theta. It's also in this little keyboard. So you can see down in the lower left corner, there's a little keyboard. So if you click the arrow, you can get pi. Pi is down here as well. And if you go to functions, there's lots of stuff in there that you can use to type as well. But I think the fastest way is just to type the word theta. Now we have a restriction here on our domain for theta. Normally for us, theta is going to go from 0 to 2 pi. So you can just type in 0 and then 2. And then to get the pi, we need our keyboard. So it's down at the bottom right by the square root. Okay. And then once you hit enter, you're all set there. Okay. Now the only slider we have for this one is the A. So you can't animate K or B, but we can animate A. And you can see we've graphed a circle. So this is really just a way that we can graph a circle instead of using x squared plus y squared equals 1. This is another way that we can use a trig function to make a circle graph. Okay. Now you can leave your sliders going from -10 to +10. And if we animate A, just click play, you're going to see how the circle grows and it flips. You scooch a little bit so you can see from +10 to -10. Okay, so really that A value is affecting the size of the radius and the diameter of our circle. Okay, so that's kind of cool to watch. And then we can change that a little bit. We have another function like that with the cosine theta. So just type over this sign and make it a cosine. And you'll see that the circle then, instead of wrapping around the y-axis, now it wraps around the x-axis. And again, we can animate A, and it's just going to flip it from the right side of the x-axis to the left side, depending if that A value is positive or negative. Okay? So you're like, hey, that's cool, I can make a circle grow. Yeah, I know, but it's just a way to expose you to that other equation for a circle. Okay? So we're going to turn that one off, and we're going to put our other equation in. Now here I have it written as A plus or minus B. You can either do positive or you can do negative. So you don't have to put a plus minus into Desmos. You can just pick if you want it to be plus or if you want it to be minus. Okay, and then it's going to have sine and theta as well. This is going to make the shape of, it's called a cardioid. So it's kind of like a heart. So let's do A, I'll just do plus, B, sine, and then just start typing theta. Okay. Okay, so we've got all our parts there. It gave me a little warning. Let's see what it says. Oh, yes, R equals. That's what I forgot. R equals. Thank you, Desmos. It's so intuitive. There we go. And now we can pop up our restriction on our theta. So just again, 0 to 2 pi. Desmos has an option of 0 to 12 pi. That's a little big. 2 pi will be fine for us for now, but you could play around with that if you want to change how many pi's you have. You can put any number, any coefficient in front of the pi. Okay, we'll learn that from 0 to 2 pi is 1 rotation around a circle. In chapter 5, we'll start talking about that. We'll talk about the unit circle. Now here we have our sliders for A and B, so we don't have our slider K. For this, I'm going to change my values for A because I don't want it to get too super big. Let me animate A so you can see what happens. Let's see how it fits on our screen here. Yeah, it gets a little big. Could kind of zoom out a little bit. So you can kind of see that if I pause it at a particular point there. Oh, that was a little, let me go back. Right about there. Okay, that shape it kind of looks like a little upside down heart. It's got this little loop in the middle. So it's kind of a circle that has like this little loop. Some people think it looks like a heart. That's why they call it a cartoid, like your cardioid areas is a heart. Okay. So if you want to change the sliders there, if you want them to go from maybe -5 to +5, that is fine. And then we're going to animate B as well. So B, you could keep that going from -10 to 10. That would be okay. So let me reanimate. There you go. And it just, it's a little easier to see in the screen there, so you don't have to zoom out so far. Now if I pause it and I animate B, that affects where it is on the y-axis. So the positive and negative B values kind of flip it up or they flip it down to the positive part of the y-axis or the negative part of the y-axis. So it's just kind of which axis the equation wraps around or rotates around. So it has symmetry. And we can animate both of them so you can see it grow and move at the same time. So I think that's really cool to watch that. And there you can kind of see that heart shape form a little more. And we can do these graphs on our TI graphing calculators as well. We just can't animate them on the graphing calculator. So I'm going to pause those sliders. And you can play around with this equation too. You can put the cosine function in, or you could make this a minus. Minus just kind of moves it a little bit. And then go up and hit A and hit B. Okay. So just play around with that. And then we can change it to cosine. So just highlight the sign and retype over that with cosine. I'm going to make it a positive again, just so we can see that one first. So you can see if it's positive, it wraps around either one side of the x-axis or the y-axis first. I hit A. Now the whole function is just wrapped around the x-axis instead of the y-axis. So sine and cosine kind of change what axis your function is rotated around or has symmetry around. And then you can animate B as well, and it kind of flips it from one side to the other. So that's kind of cool to watch. Maybe it's kind of like a little jellyfish or something like that. Maybe it's calming for you. Okay, so there's our heart one. We have one last one. So I'm going to turn that off. I'm going to come down here into this other space down below, and we're going to type in our A cosine n theta. So this is going to be a rose. And we have to do R equals, I forgot that before. So do R equals A cosine, and then we're going to do n theta. And again, once you start typing in the theta, Desmos will put the symbol in, and we're going to add a slider for n. That's one we haven't had before, so add that slider. The values for n, it's okay to go from -10 to +10. That'll be fine. For theta, again, let's go from 0 to 2 pi. So type in 2, and then remember, use the little keyboard to get the pi. Just hit enter. If you ever get like an extra little box that pops up, like an extra little empty box, just click on the X. It makes it go away. All right, so now this is really, really small, really hard to see. So I'm going to go up to A, and let's see what happens when we animate A. Okay, so right now, kind of looks like a circle, kind of boring. So I'm just going to make it a little bit bigger. I'm going to pause that, and let's go down to N, because N is really cool. N is where you can see, whoa, what happens. Now this really makes it look like a flower. Now you can see the different petals form. Sometimes they call this a rose. Different mathematicians call it a rose. Okay, so the value of n determines how many petals you have on your rose. So again, we'll see this when we get to chapter 8. And if that's going a little fast, you have this little icon here that says animation properties. It's right under the play or the pause. So you can go there and you can slow it down so it doesn't animate quite so fast. Okay. So, whoops. And let's see if we can maybe stop that at right about there. That looks pretty cool. Okay. And then if we go back up and we animate A, then it makes the flower grow bigger and grow smaller. Okay. The negatives just kind of make it flip, but you can't really see that it's flipping and going the other direction here. We'll talk about that as well, what the negative values do for when you graph in a polar system. Right? So if you wanted to change those A values here and just keep it positive, we could go from like 0 to 10. And then hit play, and it'll make the flower grow even bigger. And I'll just keep it positive. It won't flip. And you could even go from 1 to 10 if you wanted to. That way it doesn't completely go away. It doesn't get so small in the middle there. And then if you want to animate both of them, just go down, scroll down a little bit to N, and just hit play. And then it will grow in size and increase in the number of petals. So that's really cool. I think that's cool to watch. Kind of hypnotic there. Okay. So again, these are just some cool types of animations that we can do with Desmos. Okay. So I just want you to experiment with this and just kind of play around with it. If you want to try some more stuff and make your graphs even more awesome, by all means, go right ahead. Do even more stuff than what I did here. That's totally fine. But when you're all done, you need to title your graph. Okay. You can just call it animation. Okay, that popped up already. And then you can save it. And then there's a little option here next to your name where it says share graph. Okay. So here you can get your link for your graph. So you can just click on copy. And then go to the Google slide. And on the page after the directions there, I have a place where you can type your link. Just paste it right in, and then I will be able to take a look at your link and see your work and play around with your animations as well. Okay, so this shouldn't take you too long. Just have fun with it and explore. If you want to do more than what I've done, by all means, you're welcome. And as always, if you have questions, let me know.